In a world racing toward artificial intelligence dominance, energy-hungry data centers are now the front lines of innovation, infrastructure, and environmental responsibility. But three revolutionary technologies are poised to change the game forever, from laser cooling chips with light to nuclear reactors built for the cloud to AI-driven water conservation. This is the new face of data infrastructure. Let's start with something that sounds like science fiction: cooling a chip with a laser. Yes, you heard that right. Traditionally, lasers are a source of heat, but scientists at Maxwell Labs and Sandia National Laboratories have flipped that notion on its head. They've developed laser-based photonic cooling, a method that uses light to literally remove heat from microscopic hotspots on semiconductors. It works through a process called anti-Stokes fluorescence, where materials emit higher energy photons than they absorb, taking heat away from the source. This technique can cool micron-sized hotspots such as dust or manufacturing defects, which traditional fans or even liquid cooling can't precisely target. Historically, laser cooling was confined to atomic physics labs in the 1970s and 80s. It wasn't until 2015 that scientists achieved this in solid materials, and even then, it remained a lab curiosity. Now, with gallium arsenide epitaxial layers and advanced light control, it's stepping into the world of practical electronics. The impact is massive. Imagine high-density GPUs cooled with no fans, no liquid, just light. That means smaller devices, faster chips, and lower energy use. Now to our second breakthrough, nuclear power reimagined for AI. Allo Atomics has introduced the Allo Pod, a modular, factory-built, sodium-cooled reactor that can be deployed in just 12 months. Each unit delivers 30 megawatts of clean, carbon-free power, tailor-made for hyperscale data centers. Unlike traditional nuclear projects that feed into national grids and take decades to launch, Allo Pods are plug-and-play, direct to data center, self-contained and off-grid. The concept of small modular reactors isn't new. Companies like NewScale and TerraPower have tried for years but struggled with bureaucracy and ballooning costs. What Allo Atomics is doing differently is focusing not on powering cities but powering computation. Their reactors don't need massive cooling towers or complex turbines. They're built for rapid deployment, air-cooled operation, and operational independence. In a world where AI demand is exploding and renewable energy remains inconsistent, this could be the answer to stable, sustainable compute infrastructure. And finally, the third frontier, water. It's often overlooked, but cooling data centers typically requires millions of gallons of water per day. Microsoft and Google have taken the lead with an aggressive commitment to become water positive by 2030. That means they'll return more water to the environment than they use, a bold promise in an era of growing water scarcity. They've begun publishing transparent water usage data, using AI to optimize cooling, and even building air-cooled centers in water-stressed regions like Arizona. Historically, water usage by tech giants was shrouded in secrecy, but growing public pressure and ecological concerns have changed the conversation. Meanwhile, companies like Amazon, Meta, and Oracle are lagging, still using outdated or vague reporting. With environmental accountability rising and regulations tightening, water stewardship is no longer optional. It's a core part of sustainable scaling. So what do these three innovations have in common? They all represent a shift from reactive infrastructure to proactive, intelligent systems. Photonic laser cooling makes chips faster and smaller. Modular nuclear power offers clean, 24/7 compute energy without grid dependence, and water transparency ensures that the AI revolution won't come at the cost of ecosystems. This is not just the future of data centers, it's the future of how we power, cool, and sustain the digital world. If you found this fascinating, hit that like button and subscribe for more deep dives into emerging tech. Got thoughts on laser cooling or nuclear power for AI? Drop them in the comments below. And remember, the future isn't waiting. It's already being built, one photon, one reactor, one drop at a time.